Hello, Mr. Barry's class, looking at the quadrilateral worksheet. You're going to want to pause this as I move forward through this rather quickly so that you can keep up and try some of the ones that I don't do. I do more than half of them. If you at least do those, at least get that in. If you're trying the other ones on your own, don't worry about making mistakes. You make mistakes, learn from them, and you're making progress. These quadrilaterals are made from a toy building set. Judging by the appearance, classify each quadrilateral in as many ways as possible. You could probably name more, but I at least got something down for you. Number one, we're talking about a parallelogram. These are going to be parallel and square. Kind of looks like a square because it looks like they would be all equal sides. Try number two. Number three, I'm looking for a trapezoid. That's about it. Trapezoid and parallelogram, because you have to have at least one set. So you could put parallelogram here, but not all parallelogram. Well, yeah, all parallelograms are trapezoids, but not all trapezoids are parallelograms. So we'll just stick with trapezoid. For number four, parallelogram and rhombus. Okay. And for number six, trapezoid, isosceles trapezoid. Number five, you're going to want to put kites. Determine the most precise name for each quadrilateral. We're going to go with rhombus on this one for number seven. And for number nine, we're going to go with rhombus again. This one can't be a rhombus because the sides are different. So what would you call that with opposite sides being congruent, but not 90-degree angles? And all these are parallel. This one's parallel to that one. Okay. Moving on. This one, number 11, we're going to talk about a kite on that one. State whether each statement is true or false and justify a response. You may find the diagram from exercise 35 helpful, and I'm not seeing a diagram, so we'll just go with this. Oh, this is what I was talking about. A trapezoid is a parallelogram. False. But a parallelogram could be a trapezoid. That's what I was talking about earlier when I was talking about number three. So, stick with number three as it was, trapezoid. Number 39, some parallelograms are squares. True. All rhombuses are squares. False, because not all rhombuses have 90-degree angles. If they have 90-degree angles, then they're squares. Name each type of special quadrilateral that can meet the given condition and make sketches to support your answers. Okay, my sketches aren't the best, but let's take a look at these. Number 45, exactly one pair of congruent sides. Well, an isosceles trapezoid would be an example of something that has exactly one pair of congruent sides. For right angles, a square or a rectangle would have those. Okay. Back here to justifying a trapezoid is a parallelogram. False, you would say it has just one pair of sides that are parallel, not two pairs of sides that are parallel. For number 39, a parallelogram, some parallelograms are squares. Yeah, if they have 90 degrees, okay, if they have 90-degree angles, all four 90-degree angles, then they're going to be squares. And all rhombuses are squares. You could say false. Well, after false, your justification could be something to the effect that not all rhombuses have 90-degree angles. So that would be for your 41. 13, 15, and 17, putting in points. And for number 13, all you're going to do is take graph paper and you're going to plot these points. Remember, you have x, y, x, y, x, y, x, y. And you find these points and you plot them in these in your Cartesian plane, And the first one, 3, 5, was 3, 5 right there. Then your second one was 7, 6, and so on. Okay. Then you connect the dots, and you've got a rhombus. For number 15, we've got these points right here, and 15, connecting those points, we have a trapezoid. And then for number 17, we get those points, and we just get some really ugly looking thing, and connecting them in that order that they're listed, NPQR, and we're just going to call that a quadrilateral. It's just something with 4 sides. Going on to 19. In order to solve number 19, there's a little bit of math involved. So for number 19, x plus 2 is going to equal 13. So the side equals 13. So in order to figure out x, I just do 13 equals x plus 2, solve for x, and x equals 11. Okay, now that I know my x, I plug that x value in. That 13 plus 12 gives me 23. So y minus 6 is going to equal 23 also. In order to solve for y, I just set that to 23, and I get y equals 29. But the sides are 13, 13, 23, 23. The variables are 11 and 29. Going on to number 21. These two are going to equal each other, and when you take 3x minus 4 equaling x, and solving for x, you get 4/3 or 1 1/3. I just left it as 4/3. So this is 4/3, this is 4/3. And then these two are going to equal each other. So you get 6 equals y. And so 6, this y, 6 plus 1 equals 7, so this side's going to be 7 also. For 23, we're going to take, I'm going to work with x's only. They are going to be, well, this 15, since it's a rhombus, we know all of these sides are equal. So I just took 4x plus 3. So you know all the sides. I'm just going to solve for x now. And solving for x, 4x plus 3 is 15, so x is going to be 3. 3y equals 15, y equals 5 in that problem. Taking a look at number 25. 25, we have a lot going on here. I'm going to take my A and my, this one right here, I think I did. Since I know this side is 11, I'm going to take my A minus 4 equals 11. That's going to give me A, and it's going to unlock all this stuff. So A minus 4 equals 11. That gave me A equals 15. And then I took 2 times 15 plus 2. 2 times 15 plus 2, that gave me the 32. A, I just figured out was 15. Figuring out these two. Okay, these are going to be supplementary. So 4c minus 20 plus c is going to equal 180. You have that problem here. You may want to pause that. Solving for c, I get 40. And so 40 times 4, that's ugly, I know it. It's 4 times 40 minus 20. That equals 140. So this one's 140. C is 40. Okay. For number 7, you're supposed to look at this, and it does not, print well. It doesn't look good on the computer either. But there's some things you could figure out here, kind of like a trapezoid. You see some rectangles in there, some squares, a square, I'm sure. So you're just left to look at this depiction of a cubism picture and name some of the shapes that you see. So I picked out rectangle, trapezoid, square. For 29, 31, and 33, 29, Parallelogram that is neither a rectangle nor a rhombus. That would be a square. 31, a trapezoid with only one right angle. That is not possible, okay? Because if you have one right angle, you're going to have another one. So the explanation with one 90-degree angle, there must be another. And then 33, this doesn't look like it, but a rhombus that is not a square, kind of just looks like a square on its side, but I meant to draw something where the angles are not 90 degrees, but the sides are all congruent. And that would be an example of a rhombus that is not a square. Okay, try those other ones on your own. That's, hopefully the ones that I did will help you do the other ones and do them successfully. If you don't do them successfully, learn from your mistakes and you're growing.